scope, and now we are at about 543 millivolts, and that's 6 dBs also down, 6.1. It's about 0.1 dB more attenuation. So the splitter seems to do a really good job in splitting two almost equal signals out of it, or combining two signals. Now for the next test, I will check the isolation between the two input ports. So I will connect the signal generator to either of these ports, for example this one, and connect the output to the scope to this port. And I'm going to check how much is the attenuation of my signal into the scope. So here it is. The mini VFO is connected to the F1 port, and the F2 port is connected to the 50 ohm input of the oscilloscope. Now we already know that the VFO outputs 1.1 volts peak to peak at 50 ohms, and we also see here that nothing is connected to the combination port. So in this configuration we can see a signal at the F2 port, which is about 243 millivolts peak to peak, and this means that the two input ports, the F1 and F2, are isolated by only 13 decibels. However, when I load the combination port of the F3 port, the combination port of the splitter, with 50 ohm, which in this case will be the 50 ohm input of the oscilloscope, which I have just done, things are pretty different. Now we see no signal at F2 port, which means that there is much more isolation, and I'm going to change the vertical scale. I'm going to make the scope to trigger on channel 2, yes. I'm going to change the trigger level. Okay, so that's channel 2, and we are now at 2 millivolts per division scale, and we can measure 5.3 millivolts. And this is an isolation of 46.3 decibels. So F1 and F2 ports, the input ports, or the output ports if you use it as a splitter, have an isolation of about 46 decibels. And if we look at the schematic, this is just about right. There's an isolation of 46 decibels between the two ports of the mixer, of the splitter. If you use it as a splitter between the output ports, or if you use it as a combiner between the input ports. So this splitter or combiner seems to work very well indeed, provides lots of isolation, and I'm going to do a few more tests. So I'm going to do the same test at 30 megahertz, and I connect the mini VFO directly to the oscilloscope, to port 1, and I measure the power of the VFO, and it's about 900 millivolts at 30 megahertz, about 31 megahertz I would say, 900 millivolts. Checking the output of the mini VFO when it is connected in port 1 in F1, and here is the combined output port, and nothing is connected to the second input port, and the output of the mini VFO now is 437 millivolts, and that's about 6.2 decibels of loss, which is about right. Now I will measure the isolation between the two ports, but first I will show you that I have connected the VFO to the port 1, the F1, and the F2 goes to the oscilloscope to measure the isolation, and the combination port, the F3, goes again to the oscilloscope, and I will show you the difference between the F2 and the output, the combinational port, and this is it. Both ports are set for the same millivolts per division. And now I will switch off the combinational port from the oscilloscope and use just this port for loading and loading it to just 50 ohms. And I will measure the isolation between these two ports. And I can measure 21.7 millivolts into the other input port, the F2 port, and that's about 32 decibels of isolation between the two input ports, or the output ports if you use it as a splitter. So it's somehow expected, as the frequency goes up, the isolation between the ports gets worse, and you can see this from the graph as well. As the frequency goes up, the isolation between the two ports gets worse. I have actually measured a quite worst isolation in 30 megahertz, which is about there. Here is about, the diagram says about a little bit less than 50 decibels of isolation, but we are at around here, at around that point. But that's okay, there's plenty of isolation anyway, and this is at the maximum frequency that I need to use this splitter and combiner. Now I haven't showed you this test I did, but I have actually measured not only the isolation between these two ports, but also the phase difference between these two ports. Actually, I didn't measure the phase difference, but I've noticed in the scope that there was some phase difference, about 0.75% of phase difference by eye only observation. So the isolation between these two ports, I would say it varies a bit. Sometimes it's greater and sometimes it's lower, depending on the instantaneous phase difference of the two signals presented in these ports. So have in mind that. But however, the isolation is already too much in these two ports. And if you